I'm Roy Timpe, and the purpose of this video is to show how you fabricate the upright brass part for the scale and the brass part for the cross. Currently what's showing is a slideshow of the finished product with the stainless steel plates and the stainless steel balance beam, the feathers, and the box, which functions as a base plate for the 2 Corinthians 5:21 object lesson. There's a slide here that shows the nominal dimensions of the parts, which you can pause on and take notice of. Here's that slide now. The first thing we do is the first thing I show is working on the cross piece. It's 2-inch, and I make the cross in pairs. So there are the 2-inch pieces. I'm locating the center, and the goal here is to put a semicircle in the middle of each one of them. So this is in the drill press. They're held with a vise. There's a little piece of wood underneath them to prevent the drill from going into the bottom of the vise. And I'm trying to locate, get the drill right in between the center of the two bars. And then we'll drill the hole. So you can see I've marked the center with a Sharpie. It's not going to be precise, but it'll try to be precise. I'll try to get good focus here. And once I'm satisfied that I'm close to the center, we're going to turn the drill on and bore the hole. And here we go. So you want to adjust the speed and feed. Ideally, you'd like to see a long chip, long curly Q of metal coming off. That would be when you're optimally adjusted, but you get the idea. Alright, so that's finished, and then you'll see what we've hoped to do here. This will help with the alignment of the cross when we solder it, but that way the cross piece will kind of go over. It'll make that whole cross less than double the diameter, which will help it fit in the box. But you see how that works. Next, we have to drill a tiny hole for the hook, which is going to hold the plates and feathers on the cross. Again, we locate the center. This is like a saddle shape now, so I don't really need the center drill. The drill bit itself will be adequate. The center drill you'll see in a bit, but when you're trying to drill into a round surface, the drill will tend to walk, and it'll be very difficult to get a good hole. My vise jaws here aren't perfectly parallel, so I'm supporting the one end of my finger because I don't want it to slide down, which it's done. I want this hole to be perpendicular. So nominally the uprights and cross pieces are made with a 1/4 inch, and then I'm using a brass brazing rod for the hooks. And the other pieces, it's about 1/8 of an inch. So there, we're fitting the cross together, and now I'm using this actually to locate, put a mark on the cross where I want to drill it, and making a similar mark on the other cross. And you'll see why we build them in pairs, because when you're putting that half circle in, that is the drill, the center drill. So this is what you use to start the hole, because on the round surface the drill bit will just wander off and won't do a good job. So we get the center drill chucked up. And then we locate the upright for the cross such that the center drill is going to hit the appropriate spot to where we want the the brazing rod, which is going to form the hook, to go through. And unfortunately my hand's in the way, but you get to see that that's thicker than the drill bit, and it just kind of comes in and makes a nice mark. And then we can follow that up with the drill bit. Now I'm doing the second one. Okay, so once we've got it marked like that, the the drill bit won't walk, and we can make the hole just the way we want it. It's better to video too much than too little, because we can cut it out. Okay, I'm using the hand drill to finish up the hole. I'm using a piece of scrap wood to protect the drill bit when it gets through the brass. Now we're making the marks on the upper part of what will become the vertical piece that holds the balance beam. And we got to drill through this, and then we'll put a piece of brass rod, brazing rod in, and make the hook which holds the balance beam. And again, we're using the center drill. Making sure I'm happy with the location of the hole. Are you filming? Now we're going to bore holes in the bottom. I got to make sure I put the bottom end. This is one of the balance beam verticals. So the hole that we put in for the, little hook is inside that chuck. And then we're taking the center drill and we're going to mark the center of that. And then we're going to follow that up with the with an actual drill bit to drill a hole in there, and we're going to put a piece of that brazing rod in that'll serve as a peg. It'll serve as a peg for the so the thing sits up vertically in the wooden box. So that's all we need here, is just a mark in the center that's deep enough for the drill. And I'm actually going to mark all of them and then re-chuck them and drill them. So it's all 4 of them. And we have to make sure, here's the cross piece. We have to make sure that we're going to drill this hole in the bottom and not the top. So double check that. Ask me how I know. And this is the final upright for the scale, for the balance beam for the scale, and we're making sure that we're making this mark on the bottom of the brass. Now we're going to switch from the center drill to a drill bit. And I'm just drilling the hole in, perhaps a 1/4 inch or maybe a little more than a 1/4 inch. So at this point I want to bend the hook, which is going to go into the top of the balance beam. And you can use one of the, either the cross piece or the balance upright, and the socket you made in the bottom can be used to help you bend a tighter radius with the hook. And a minute back. And we'll bend this end back up. And I want it all in one plane. It got a little bit out of plane when I did all that. I was happier with the first one I did than this one, but that's the first one. I like it a little tighter. But they'll both function the same. It'll function just fine. So now we just have to cut them off. Necessary to cut about halfway and then break it is easier. I'll deburr that using a sander. There's a belt sander, stationary belt sander on a bench that I'll basically use to deburr these things, like the brass rods that I cut for the uprights and the cross pieces, I deburred on the belt sander. Here is deburring. There's a sanding disc in front of me you can't see too well, but we're basically making that jagged edge perpendicular. And then put a little chamfer on it so that it goes into the holes that we drilled smoothly. So that's how it's going to look. It's going to get silver soldered together. And I'm dressing up the end of this, and I'm going to cut a little piece for the pegs that go in the bottom of the cross and the bottom of the upright. So just making a crude measurement there using my fingernail. Flattening out the end and then chamfering. Okay, now we're dry fitting the parts just to make sure everything works. I'm going to end up assembling these parts with flux so we can solder them together. So when we solder them together, they've got to be absolutely clean, which the parts we drilled, of course, are, because they haven't had any time to get any corrosion or anything on them. And it's good to scuff up the other parts with some steel wool or light sandpaper. So I'm putting the flux on there. The solder will follow the flux, and the flux will clean the metal so we get a good metallurgical bond, and the solder wets the metal. So basically putting everything together, and we're putting flux where we want the solder to be. So these are the pegs. And the hooks for the uprights. Actually, I think this one gives me a little trouble. I probably didn't get enough flux on this upper hook, but you'll see that later when I solder it. So now they're chucked up with the flux. I'm going to come in with a propane torch. And the metal itself has to be hot enough to melt the solder. The metal, the solder will melt, and then it'll travel up that thin capillary gap between the two pieces of metal. I mean, the gap is probably only 1/1000th of an inch or so, maybe a little less even. But if the metal's not hot enough to melt the solder, it won't wet the metal, and you won't get a good bond. This is the one that gives me a little bit of trouble. I get it hot enough, but the solder is not wicking into that joint. I think there may not be enough flux. See, it's falling off and not wicking into the joint. Okay, this one's working nicely. You'll notice the brass turns a little red as we're soldering it. Brass is I'm putting a little more flux on the back of that. Brass is mostly a combination of copper and zinc. And I think in the flame, something's happening to the zinc, and we're getting a little bit more of the copper showing. But now that worked. That little solder blob sucked into that hole and anchored that hook. I'm going to get to the bottom of this. I guess we didn't get that before. I had a little bit of flux on the end of the solder, and I just use that as a tool to get the flux onto the piece. Now these are the uprights for the crosses. I'm going to solder the pegs in the bottom. So I want you to see how when you get the metal hot enough, the solder will just go into that capillary. And that's actually enough solder right there, but see it soaks into goes into that void where the flux is. Now we're setting up for the crosses, and do these in pairs. With that semicircle, it'll tend to self-align. But we put this together with flux. So I've got both of them, and they're sitting like this, and they'll tend to self-align. Trying to get that in focus. Coming in with some more flux. And again, we got to get the metal hot enough so that it melts. The metal itself is hot enough to melt the solder. The flame will melt the solder, but if the metal isn't hot enough, it'll just roll off. I'm trying to get this into the semicircle. It wanted to move a little. Like it as tight as we can. Now, while it's still hot, I want to make sure that I get the thing perpendicular. I actually got to heat it up a little bit to get the solder flowing again. And then I want to adjust the cross to try to get it at a good right angle so it looks aesthetically pleasing. So while it's still hot, I'm going to grab it. And tweak it. Now we'll do the other side. Having the brass rod for the hook go through both cross pieces just gives it a lot more mechanical strength than it would have with solder only. And then we're going to do the perpendicular adjustment and hold it a little bit until the solder solidifies. Okay, now we want to wash the flux off. Scrub these up with a bit of a Brillo pad and a slight abrasive like Comet. I'm actually using Gojo with an abrasive in it. But the flux is almost grease-like. I'm just taking them over to the sink. Now we're going to cut the crosses free from that metal brazing rod. Leaving an appropriate amount out to form the hook. We're going to deburr and slightly chamfer that. I'm gonna bend the hook. It's actually nicer if you have another rod with a hole in it rather than using pliers. But the pliers do work. You want to make sure you've left that long enough so it'll be able to, take the sin plate and the feathers. Now I'm going to remove some of the solder blobs that are on here. I'll just use a belt sander to make that look better. The cross has a solder blob on it. And I can't quite get in with the belt sander because of the cross piece. So I'm going to switch to a file. Just want to make it kind of smooth, get rid of any burrs left from the sanding there. I'm going to go back for some more cleaning. Now I'm checking the length of the cross arm to see if they're equal, and they're usually never quite equal, and I'll just trim whichever one is longer. So just trim it down and then chamfer the edge. I'm doing the other one. chamfering the edge that I trimmed because there's a burr left on it from the disc sander. And it doesn't have to be precisely equal, it just has to look, good to the eye. It's not like it's a critical part for the inside of an engine or anything. I'm trying to show you the measurement again. It's like sometimes the camera's not focusing on what I want it to. Now just sort of sanding it with some sandpaper to get rid of the copper color and get us back to a mostly brass color. Now, the brass will tarnish unless we coat it. We're going to coat it with some crystal clear Krylon spray paint. I just stick the pegs in a corrugated cardboard box just to hold them roughly upright so we can shoot them, with the crystal clear Krylon glossy paint. So we'll let that dry a while. It dries rather quickly. While that's drying, we can work on the feathers. This is a feather duster that was purchased at Walmart a while back. Grabbed 2 feathers. And I'm using some, like number 10 electrical ring crimp-on connectors. Here I'm using some shoe goo to glue it. I've also used epoxy. But shoe glue is handy. I happen to have some and it'll work fine. So the thing to do is to pack it in there. I mean, normally the wire would go in here and the crimping tool would crimp it down. But now the important thing with the shoe goo is kind of viscous compared to epoxy, so we've got to make sure that we wet the feather pretty well and get the actual stalk of the feather. I mean, the same is true with epoxy, but you want to make sure, and you don't want to glop glue down on the fluffy part of the feather. And just push it in until we see the feather come out the other end of that tube on the electrical connector. Just repeat the process. And again, you got to make sure that we actually wet the structural part of the feather. So I'll just leave them there to dry. Now this is the final check on one of these boxes. Sometimes you have to ream out those little holes in the box with a drill bit. They may have burrs on them from when the box was manufactured. Make sure that everything fits. I like to put the plates in with the writing down just so the writing doesn't get scratched. The writing is robust, but and then just fit everything in such that the box closes. I like to leave the feathers in some plastic to try to keep them from getting messed up. Put the business card in, which tells people how to get to the video instructions. And the cat is a final quality check.